Ta-da! So as you can see behind me, we have a new product that we're going to be talking about today. But really, you could look at this as two things. Either way you want to look at it. This can be a look at our new combination bench, or it can be you can be watching John Jones' agility course this morning, because I'm hoping to just dodge all these cables around here and not bust my rear or bring something crashing down. So I think that's probably, for me personally, that's kind of more my goal, just to finish this thing without breaking something. So today we are going to talk about the model 8803A bench, and it is a combination bench, as you're going to see here in a minute. But let's get through some of our other stuff first here. Go through my clicker. So we've got, as you can see today, we're doing the 8803. We're going to be talking about it, the combination bench. We're going to go over an overview of it and show you some area scenarios on how to do it. But first of all, let's throw out a quick prayer and then we get rolling. Father, thank you so much for a beautiful fall day here in Knoxville, Tennessee. Just thank you so much for we can see you working behind the scenes of what's going on in this country right now. So many people right now are turning to you and praying to you. And Father, I hope that just increases and we keep turning to you in this what looks like could be some rough times ahead. But Father, as long as we've got our eyes on you, everything's going to be fine. So thank you so much for, as I said, beautiful day today. Hopefully we're going to learn some things that are going to help us with our jobs, but more importantly, help all these folks in our industry to get home safe, Lord. So all of these things we ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. All right, let me get geared back up. All right, so we're going to talk about the 8803. So the 8803, as you know, we've been talking about for a while now. We've got two other benches that we've been talking about. We've got the 8833 and the 8813. The 8833 is the transformer rated bench, and the one that I've usually been standing in front of, right? The 8813 is the self-contained bench. We had separated them. We separated them because we had utilities tell us, normally our techs work up to a point and they usually work just on the single phase stuff and the self-contained stuff, but then as we get going, then they become a meter tech 2 or however the designation is, and now they start getting into the transformer rated stuff, the higher revenue customers. And so there's a little bit more involved in it. So that's why we delineated between a self-contained bench and a transformer rated bench with the first offerings that you've seen. Okay? You can be more specific, so you can have just guys that are up to that level now, they're ready to get into the transformer rated stuff, they can get on the 8833. But if they're coming up through the ranks, you might get them on the 8813 so they can learn the self-contained stuff really well before they move into the 8833 bench. Then we had people ask us, well, what if, for a couple of reasons. One, we don't have the money, to be straight up honest. We don't have the money to get two separate benches like that. Also, room-wise, we don't have that much room. Is there any way you could do a bench that had both? So that's what we've done here. We have got both self-contained and transformer rated on the same bench. To do that, obviously, we couldn't have every form out there. We couldn't have every service out there to keep it just in the smaller size and one bench. Okay, so we had to give up some of that stuff to make it into one bench, both self-contained and transformer rated. Okay, but this gives us a combination of all of it. So it's still portable. Got the same casters. You roll it around, lock it down. None of that's changed. All of those drawers, the no slamming drawers are the same. You can see in the picture there, wooden top looks, the same, looks very, very similar. It's just that in this case now we've got a transformer rated meter on there, and then we've got self-contained all in the same one. And we've still got area scenarios that we can throw at you. So we've got 30 area scenarios that we can throw at you, just like you've seen on the 8833 and the 8813 up to this time. Okay? So let's go to the next one. So the supported meter forms, you have a 1S, 2S, 12S, network, 16SY, and a 9SY. We don't have a Delta service on the 8803A because the size and everything and trying to keep it small like this in a combination, we had to lose the Delta service. So that's why you're seeing here just 12S network now. So we can't do a 12S Delta. And we can't do the 5S Delta you saw on the 8833 that you've been watching all these weeks. So there is a trade-off that you have to get it all in one. And unfortunately, one of the trade-offs was we couldn't do the Delta service. Okay. So if you want the Delta service to be able to train your guys on, you're definitely going to need the 8833. Okay? So now let's go over the different, the comparison now. You can see the very first column there is this new, the 8803 we're going to be looking at today. Just to the right, it's the 8833, transformer rated. Then over to the far right is the 8813, which is the self-contained. You can see here we're showing just meter forms and what's supported on it. And you can see that just as we've been talking about for weeks now, the 8833 is all of your transformer rated stuff, right? So 3S, 5S, the Deltas, the 6S, the 9S. But now with the new 8803, you can get the 9S service. You can do a 9SY, you can see down there. Okay, so I can get that a transformer rated service, which is a 9S right there. Now the 8813, far right, you can see it was set up, and you've seen it is all for just the self-contained stuff. So if you go to the far left over there, you can see the model 8803. It also has the 1S, just like the 8813. It's got a 2S just like it. It's got a 12S. But remember, it doesn't have the Delta. So it just has the 12S network. It also has a 16SY. Okay? And then over far right, you remember you've seen before in the 8813s, we set up that separate circuit to train on a probe well. Okay? So you can see the differences there in that this is a combo in that it's got the 1S, 2S, 12S, and 16S, no Delta, but then it's also got a 9S on there. So you can train guys on self-contained, and you can train them on the transformer rated, testing the CTs, the PTs, and all the other stuff. Okay? All right. Now, let's go to the looking at the different scenarios and other stuff, a comparison. So you've got the model 8803, same columns. We got the new one on the left, center is the transformer rated, far right's the self-contained bench. You can see number of scenarios. With the other benches, we have more scenarios, clearly. You can see you don't have a tablet now, so I don't have an admin per se. You can turn the screen and do that, and one person can stand here and be the admin, but also you can have a do-all. One person can do everything on the one bench on the new 8803. You have to have an admin for the 8833 and the 8813. This one you do not. Okay, so it's not required to also have an admin on this. All right? The bench interface, though, is the same on the 8803. You've got a touch screen right here on it that you're going to see here in a second. You've got a touch screen right here on the actually mounted onto the bench that you use to run everything. So it still does have a bench interface there. But you can see the differences between the new one and then the 8833 and the 8813 in that you just have the admins involved. You can keep a curriculum of number of hours. All of that is done within the unit. You would have to keep track of that with the 8803. You'd need to keep track of somebody's hours. Okay? Okay, so customizations, the 8803, since it's the economical model, it's going to be standard on the colors. The CTs, it's going to be a 200 to 5 on the CTs or a 2 to 1 on PTs right now. Excuse me. So that's, with it being the economical model, it's just like anything else out there you buy. It's going to be more standardized. The 8833 and 8813 are totally customizable, so that's going to be one of the big differences. Try and keep the cost down and keep it standardized. For us, from a cost standpoint, you're not going to have the standardization you do on the 8833 and the 8813. Okay. All right. Let's take a look at this bad boy. Water off here. So as we talked about earlier, you can, here's the screen right here. So you can use the screen, and it's touch screen. So if you wanted to, you could turn the screen and have someone standing there loading in the scenarios, or you can do it all yourself. Okay, you could just turn the screen and have someone be the admin, if you will, and they could stand there and they could run you through some tests, or you can do it all yourself right here, touch screen. Okay, so that's one of the big differences. That admin component is now not involved in the economy model here. Okay, all right. So we're going to go here, and I'm going to start out on a 16S right here. So I'm going to go ahead and hit 16S right here. And then on the 16S, you can see my error scenarios are right here. So let's go ahead and just run a normal test first. So I'm going to run just a 4-wire Y, a normal test. So I'm going to hit select. And you've seen this screen many times on our webinars. Make sure you got your PPE on. So we're waiting for it to stabilize. You can see it said stabilizing. You know, the screens there's not a big difference in these screens. You're going to see a lot of similarities in the screens on here. You know, where you're seeing stabilizing and then that it's ready. And a lot of this should look familiar to you. So that's what we were doing a minute ago. We were just waiting for it to stabilize like we've done on the other webinars you've seen us do. So I've got here, I'm connected up to my 16S. So you can see here, and by the way, if you can give me a view out here, are we looking at this right here right now? Wide shot? Good. Okay, thanks, JP. Because I just wanted to show, we got the 1 and 2 S's over here. You can see right behind my case right here, I got the 1 and 2 S's are right here, right? Then I got my 16S right here, okay? And then I've got my, so a little bit different. Remember we had our CTs were over there before, so I guess I should have gone over this. So the CTs are over here now. So I got my CTs are here, okay? Then I've got my 9 right here, and then I've got my PTs right there, okay? So they're in the same spot, but these have moved from that side over to this side now. The CTs have, okay? So the CTs are over here now, all right? So, but just like you, oh, that was, I know I moved at that time. Nice, okay, okay. Remember, you've got the cut. We said before, you got a light above knowing which one of these is hot. And we still have the safety features over here, turning everything off. I don't want to skip anything. If you got any questions, you know, holler in on the chat room. But the turn-offs to be able to kill everything is the same over here. I've also got the light indicating that my socket's hot. Okay? All right. So I'm in here. I'm just going to run a normal test on this 16S right now. So I'm just going to run a meter test here. I'm going to do a custom load test. So I've got you can see my voltages are right here, connected right here across the top. And I'm using some clamp-ons right here. I've got some 353 clamp-ons right here, 200 amp rated. So I've got those right here. So I've got my 3 clamp-ons down here at the bottom picking up my currents. I've got my alligator clips right here picking up my voltages. And I got my pickup right here. So I'm going to run it for 30 seconds or 3 revs. Y'all know I like to do that in case I hardly have any load there, so I don't have to sit there forever waiting on 3 revs or pulses. It's always going to show us that layout. Y'all are used to seeing that. Well, I won't wait. I usually wait for 2 pulses. That's the way the professor told me to do it, so that's the way I always do it. Y'all know that. I started to mention something in the prayer about thank you for the football because a lot of guys got their football fixed this weekend. LSU didn't play, but I mean, hopefully they'll play next weekend. I can watch them. I tried to tell everybody. Nobody would listen to me. I said, we lost everybody. We lost coaches, players. We're decimated. Nobody would listen to me. All right. Okay. So done. So we're set up at 99.489, which for the clamp-ons and that 16S right there, that's not that bad for the situation we're in. So we're going to hit done right there so that I've tested it normally. So now I'm going to go up here and I'm going to show you how if I were going to do it, I would go ahead and put an error scenario on there. Okay? So what I would do is I would just hit stop. And I'm going to go back to, since I'm on a 16S, I'm going to go to 16S. And here are my scenarios, and I've got the 4-wire wide normal one. I'm going to go down here and just pick one, let's see, how about missing C-phase voltage? Remember, this could be turned and somebody else could be doing this, so I wouldn't see it. So let's say I have a non-ranging meter out there, okay, and it doesn't auto range, okay, so it's only a 120 volt meter, okay, 16S meter, and I try and put it into a high C leg installation, so I can get 208 on that C leg, right? And if it isn't auto range, I could smoke that voltage element on C phase, right, on that high C leg. So this would be an example of that. All right, I've plugged it in there. It's not auto ranging. It'll only handle 120 volts. And then they started turning on a bunch of stuff on that 208, and I smoked that that C leg voltage. Okay, so that's the one that I set up for right here. So here's where it's a little bit different. You know, I can see it right here, so I can always see it. So that's why you might turn the screen and have someone else there. But if not, I mean, you're recognizing here. In a moment, you'll see when we're doing the 9S, it'll have both the primary and secondary. But right now, of course, for self-contained, all in one. So right now, I'm looking at that, and I can see I don't have a C phase voltage vector right now. Right, I'm right on the axis right now. You see the little arrowhead right there, the blue arrowhead? That means I know right now, but remember, I'm the one that punched it in, so I know. But right now, I can look at that vector and see that. So we're going to go over to the machine and look at it and see the same thing, okay? So we've said before that what you should do is you should take a look at the vectors beforehand, right? Before you really get going. So we preach it and preach it. So when I look at it, just what did we just say? We saw it on the screen over here. So when I look at my vectors before I get going, I already know I've got an issue because I don't see my C-phase voltage vector. My open arrowhead, which is always the voltage, the open arrowheaded vector, I see it over here on A, I see it over here on B, it's missing on C, and then I see it's right down here at the axis. So I can see I don't have any current right now on C-phase right now. So I can see that I'm way, way, way low, right? So excuse me, my voltage. So my voltage is way, way, way low. And if I look right here, see I got 120 volt, 0.12 volts. Okay, so I can see I'm missing my voltage on C phase. So I already got a pretty good idea what the problem is. Okay, pretty good idea here. So I'm going to hit previous. I think I've seen what I need to see, so I'm feeling pretty good about it. So I'm going to go to customer load test right here. And customer load test. Finger happy, I want to put 30 seconds right there. There we go. All right. So we're going to do the same test again. Now for Chris and I talked about this a little bit earlier. So if I have this this scenario here, what would I expect the effects to be all the way around? So now I'm missing my voltage on C phase. So I'm missing the voltage on C phase, and obviously my watts on C phase are going to plummet, right? My watts on C phase because it's voltage times current times power factor. So I'm going to be losing watts on C phase. So I would expect one thing is, let's continue anyway, it's already picking up that the voltage is already way too low on C phase. So the machine's already recognizing there's something not right. You know, it's a little different. I've always noticed it. I think it's funny. On these little balls that light up, if there's an issue and it knows it already, look at that first ball. It doesn't light up. You ever notice that? I noticed that out in the field after a while. So I can already, the machine knows there's an issue. It's telling you there's an issue. So let's take a look. It told you, it gave you the message on the screen saying it was missing a voltage. It didn't like that, right? And it is. So it told us correctly what was going on there. What's another thing we should be noticing right now? This is something that we talk about. We talk about all these little clues. Well, what did we notice here? It's taken a long time to get my pulses. It didn't take that long before when I ran the normal test, right? So it's taken a lot longer. Excuse me. Excuse me. So it's taken a lot longer to run it, right? You would also notice, if we'd made a note before, you should have seen less watts. Because remember, no voltage on C phase now, so the watts on C phase are very, 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 very low. So I've gone down on my watts from a normal test to the problem test site now my watts have gone down. So taking longer between the pulses. It takes longer between the pulses. Okay, I'm noticing my watts are a lot less now than I know should for this size of a site. So all these little things are giving me clues, and I noticed my vectors were jacked. So I pretty much have got this diagnosed. I've somehow accidentally I've smoked the voltage element on C-phase, right? But you can see it's still testing okay. But we notice I think we're like at 5,400 before, something like that. So we're at 5,400 watts before, and we've dropped down to 3,587. So you can see we've made a big drop on our watts. Took a lot longer to run, and the vectors were telling me that the meter element, looks like to me, has gotten smoked because I don't have exterior stuff, right? So it's all got to be inside that meter. So there's something wrong with that inside that meter. I'd say we probably took one that wasn't auto ranging, put it in there, and got a high C leg and smoked that C leg element on the voltage. Okay? So now we'll go over to the 9S. I'll move my connections over to the 9S meter, and we'll go over and connect it up. All right? Don't want to fail my agility test. All right. So I'm going to come over here. So I got my voltages connected over on the 9. I need to move my pickup over here. I think we're good to go. Okay. So I'm going to deselect this site because I was on a 9S site. I was on a 16. So now I'm going to go to a 9S site here. Okay, so now I'm on a 9S site, so I can perform my tests on a 9S site, but I got to come back over here. So what I'm going to do is I'm going to hit stop, and I'm going to go over to a 9S, and we're going to go normal, and hit select. Gotta make sure I got my PPE on. Sure. So in this case, remember I barely mentioned it a little while ago. Now it's going to show you the primary. You can see it's even labeled primary and the secondary vectors, okay? So whoever the instructor is, if you are going to have an instructor who's got it turned, he'll be able to see the primary and the secondary. Or you as the trainee, if you're the one operating it yourself, you'll see both the primary and the secondary side. Why is that important? Remember all these different webinars where we've talked about the problems over on the primary side. So the secondary always follows the primary. So in this case, you'll be able to actually see what's going on between the primary and the secondary right here on this screen right here. Okay? So we will run let's run a meter test. We'll run a customer load test on here. And 30 seconds or 3 revs. Start her up. Okay, go next. Got a pulse, so that's good. Looks like that's something we can live with. 99,979, 99,977. All right, then we'll test our CTs real quick, and then we'll put an error scenario on there. And it's one of the ones that I like because it allows you to use more functions on the test kit. So let's go to, and make sure you check the double wrap box, right? Because I've got them double wrapped, or it's going to think they're 400s instead of 200s, or 600s instead of 3s. It'll double her up. So you got to make sure you check that double wrap box. And you can see I double wrapped them, so had to check the box. So we'll go next. Okay, so that would be just a normal test, normal setup. But now let's go ahead and put an error scenario on there. All right. So I'm going to come over here. Just like we did earlier, I'm going to stop it. Then I'm going to go 9S. And let's see, how about, what you think, Mullins? What number? 23, okay. Ah, okay. Well, here, you can. Oh. See, the people without the mic suggesting the guys with the mic to do, okay, I see how it is, okay. So you got the normal error scenario. I've got phase faults to where I have no primary current here on A, B, or C phases. I've got phase fault. I've got no voltage on C phase. I've got wiring errors, reverse polarity on primary, reverse polarity on the secondary side. I've got clockwise rotation problems with the, actually if they've rotated their wiring off as far as their phasing. Both the counterclockwise or clockwise directions, and then the sweep when they've got the incorrect size CTs on there, which is pretty cool. So they can simulate if you had two 200s and a 400-5, and you had one of them that was the wrong size. So all of that's in there. So I can pick any of those. I'm going to go ahead and pick 23 right here. The reason I want to is we can put problems on the, and we talk about this, using the machine to show you problems between primary and secondary. There is always that general rule, right, that the secondary is going to follow the primary. So if I have a problem on the primary, yeah, the secondary will follow that. But I need to know that if I'm trying to troubleshoot the situation at that installation where the problem is it on the primary side or the secondary side? Because it also decides what personnel have to be out there, right? Probably if it's primary stuff, I'm going to get some of the linemen out there. So it's definitely a big deal to decide whether it's a primary side issue or a secondary side issue for us as techs. So I've selected one. So while it's getting ready, it's stabilizing. All right, it's active. Okay, so let's start out. So if we're going to test this site, remember we always say we're going to try the vectors first. So let's go ahead and try the vectors first. Okay, so when I look at that vector, I see that on A phase, my red vectors, which are A phase, I have polarity reversal on them. I am on 180 degrees out on there. If you look down here, this is showing my secondary voltage and my secondary current because I can hit this button and change it to primary current if I like. Okay, so right now I'm looking at secondary side. So I know that I definitely have got a problem on the secondary side. But what have we talked about and trained about and are getting used to doing more when we get out there? If I see some problem right away, I need to, if I leave it without being in a test, remember, I can go ahead and toggle between primary and secondary stuff. So in this case, I'm going to take a look at the primary. Oh, so I didn't get any change between my primary polarity reversal and my secondary polarity reversal. Remember, one of the tricks that we use out there, it's an excellent tool for us, is if I rotate, if I go to that primary vector and I look and the primaries look good, and then I go back to the secondary vector shows polarity reversal, chances are I'll probably have those wires swapped on that CT, those secondary terminals. But if I do what I just did here, if the primary and the secondary are both showing polarity reversal, then the secondary that we initially turned on and saw on the machine, that's just because it's just on secondary. But the real problem is when we toggled, looked at the primary, and we found the actual problems on the primary. So in this case, I would say I have polarity reversal on the primary and not the secondary. Okay, that's what I'm thinking on this one. Because of using this button right here and looking at the two of them, right? And I'm not getting any change. So now I think I pretty much know what it is. So let's go ahead and test real quick and see what happens, all right? So I'm going to go ahead and test the meter. So I'm going to run a customer load test on the meter. And I'm going to go 30 seconds or 3 revs, like we always do. And we'll hit next. So notice it took a little while. And when you're out there, you're just taking all these clues in, right? You're looking at all the clues. You're listening for humming noises, right? Because what happens, you get out there and you get a loose connection over time, it just gets loose, and it starts rattling and vibrating. So you're listening, you're looking, and when you take all these little clues in and you take them all in there, you're melting them all together, and you go, okay, I think I know what the problem is now. And to me, that's why I think that's such a big deal, to be able to tell whether the problem's on the primary side or the secondary side. Because, when you finally do say, I think we got a problem on the primary side, that's what I mean. Then you're going to have to call in the bucket trucks, the linemen, and go up there and check everything. So you want to make sure you know what you're talking about before you do that, okay? 100.205, so we're getting in their pocket just a little bit. Test complete, because it's run slower, so she got test complete. So I had it 30 seconds or 3 revs, right? So we're done on that one. And now we can previous out of that, and we'll run a quick CT test. So what's everybody expecting us to find here? Are we going to get errors everywhere and all this because we've got polarity reversal, and so we should be getting a bunch of errors over on the CTs, right? So we should just be getting fails, and everything should be looking horrible, right? What? How could that be, Chris Mullins? There's no way in the world that could pass. We have just, through our detective abilities here, determined that we think that the primary's actually got polarity reversal on it. So how in the world could these CTs be testing out and passing? I don't understand. Oh, wait a minute. All they're doing is they are just looking, and they're doing a comparison. Let's think about what happens when we do let's think about this for a second. When we just did that CT test, we've talked about it before. Let's talk about it one more time. So my primary has polarity reversal on it. So my secondary follows the primary. So I've looked at both of those vectors. It showed A phase being 180 degrees out. Both of them showing polarity reversal, right? Well, if my A phase primary is followed by my A phase secondary and they follow with one another, they don't see a problem between those two. So between those two, there isn't polarity reversal. Both of them are 180 degrees out, right? So both of them are falling in line with one another. So I don't get the phase angle error on there. I don't get the polarity, big polarity reversal messages all on the screen and everything, because it's the ones following the other. So as far as the two of those are concerned, they're both in line with one another, right? So I would have to have, if the secondary was out of line with the primary, then I definitely get that. But if I've got, that's why I got to toggle and use those buttons to determine where my problem is. If I just ran a standard test on here, everything would look cool, right? But if I started, that's why I recommend, and we recommend as a company, always look at those vectors first while you have the chance to toggle between the primary and secondary before you get into the test. A lot of guys miss primary issues because once they're in the test, they don't have those tabs there to be able to toggle back to it. They just get rocking and rolling. We get out there in the field and we want to get the thing done. If you had went to this site and you'd have tested, you'd have tested pass on the meter, pass on the CTs, let's go to the next one. Okay, but it's not really correct, is it? And that's why you should look at that. You should double check your primary versus your secondary when you're looking at those sets of vectors. You can toggle between those two tabs and take a look at them. And in this case, there definitely is a problem that needs to be corrected. But just testing on that secondary side, testing those CTs and that meter, you wouldn't see it. Okay? All right. What else, Mullins? Okay. So the director and the producer are telling me that, I guess, I made it through today. So, oh, okay. If you want to find out more information about the bench, then just click on more info right below the picture of the bench. On the screen. Okay. The button is right beneath what you're watching is what they're telling me, and you just hit the more info button. It'll give you more information about this. Oh, nice. Fill out a form, contact the sales folks here, and that way we can get you more information, pricing, quote, whatever you do need, more information, questions answered. Hopefully you can see what we've done here. We had the two benches. We had the one that was just self-contained, the one that was just transformer rated. We had those, and then we just did similar to when we were asked about the 3 Series. Can you make something a little bit smaller? Can you make it a little bit lighter? We listen. And we try and do that. I mean, straight up, you know what part of the company I'm in, we all wish that everybody could move faster than they could to get things done. But to do it right, go through all the engineering, all the testing you have to do, everything, all the codes you got, everything you got to do. But we were asked about this, we've worked on it, and now we got it ready. So this would be if you didn't have the money to get 2 separate benches, if you wanted to combine everything into a smaller area. All of it's right there, but you can train someone on how to test a self-contained meter and also a transformer-rated meter. Got any questions? Please holler at us. We haven't determined yet what next week is going to be. Excuse me, I won't be here. I'll be up installing one of these new benches at customers. So I'm not sure what they're going to be doing next week, but y'all have a great week next week. God bless. Be careful out there, all right? Thank y'all.